Hi bro, is this Sriram Shopee? I used the pen that you gave me and I actually passed the mathematics exam. I am very happy today and I want to buy a Rubik's Cube and I'm ready to pay 10 times the MRP of the Rubik's. So how much does a 3x3 cost? 100 rupees. Fine, then I could pay you 1000 rupees for it. So how much does a 4x4 cube cost? 200 rupees. Then I could pay you 2000. So how much does a 5x5 cube cost? 250 rupees. Okay then. Can you please deliver the cube to my home and I will give you 2000 rupees cash? Bro, please wait. I know 10 times 250 rupees is 2500. All the money I do have is only 2000. So how would I able to pay you more than what I have?
Hello everyone, welcome you all to another video on EMI Labs. This is another video on amplifiers. So amplifiers are the circuit which is used to amplify a lower voltage level signal into a higher voltage level signal. In this aspect, can I use an amplifier to generate a higher voltage signal? For example, I need 1000 voltage power supply for my design, but all I do have is 1 volt. So can I use an amplifier with a gain which is set to 1000 in order to get a 1000 voltage output from 1 volt input? Have you ever thought about this? We are going to discuss. Welcome to today's video. Before we move on, let us understand two important terminologies. Number one is power and number two is signal. Power is an electrical energy which is required to operate a circuitry or an electronic load. It is like a fuel to a motorcycle. Signal, on the other hand, is also a type of electrical energy. The main purpose of a signal is to convey an information in some form. For example, let us assume a thermal sensor. The output of this thermal sensor is capable of generating an analog voltage in the range of 0 volt to 5 volt. By actually measuring the output voltage of this thermal sensor, we would be able to estimate the temperature which is being monitored. In general, the operation of an amplifier is usually explained with an example of a pen. A pen being held in this position, a small change which is applied on the shorter side of the pen, and you could find there is a large change on the other side of the pen. And similarly in an amplifier, a small signal goes in and a large signal comes in. Listen, this is not a proper representation of an amplifier. Because of this, many engineers wrongly interpret that the weak signal entering into an amplifier somehow magically transforms into a larger signal. In order to get this amplification work to be done, we need electrical energy to do that. So that is where the power supply of this amplifier comes in. Let us try to unlearn and relearn the operation of amplifier for the purpose of better understanding. The input signal which is entering the input pins of the amplifier is not getting transformed into the output. Instead, this input signal is used as a reference signal so that the amplifiers can generate an amplified version of this input signal. If input signal is not getting transformed into the output signal, then from where do this output signal come from? The output section of the amplifier usually takes the power supply to which it is connected to and it generates an amplified output. Let us consider an op-amp based non-inverting amplifier circuit of gain 10 and it is connected to a power supply of plus 15 volts and minus 15 volts. Let us assume the voltage at the input of the amplifier is plus 1 volt. The expected output voltage of this amplifier circuit would be 10 times 1 volt, which is 10 volt. Where do this 10 volt come from? The output section of the amplifier takes the 15 volt power supply and it drops 5 volts within its own circuitry and gives out 10 volt on its output pins. Let us consider an input voltage of 0.5 volts. In this case, the amplifier output takes plus 15 volt power supply, drops 10 volt within its own circuitry and gives out 5 volt at the output pins of the amplifier. Let us consider another example with a negative input voltage. Now the input voltage is minus 1 volt. In this case, since the input is negative, the output of this amplifier takes the negative 15 volt power supply and drops 5 volt within its own circuitry and gives out minus 10 volt as output. Let us try to plot an input to output characteristic of this amplifier circuit. X-axis corresponds to the input voltage and y-axis corresponds to the output voltage. When the input voltage keep on increases from 0 volts, 0.1 volts, 0.2 volts, etc., the output voltage would be 10 times of the input voltage. When my input voltage is equal to 1.5 volt, the output voltage would be 15 volts. If I keep on increasing my input voltage beyond 1.5 volt, like 1.6, 1.7, 1.8, The expected output voltage with a gain 10 would be 16, 17 and 18 volt. But in this case, our amplifier is connected only to a plus 15 volt circuit. The amplifier circuit cannot take a 15 volt power supply and give out a power supply higher than 15 volts. For any input voltages higher than 1.5 volts, the output of the amplifier will stuck to plus 15 volts, and this is termed as output voltage saturation. In my intro video, you would have seen I wanted to buy the Rubik's Cube with the 10 times higher value of its original worth, which is 250 rupees, but I gave only 2000 rupees because the money all I did had got saturated. Similarly, for a negative input voltage, any voltage which is beyond minus 1.5 volts, the op-amp output would get saturated to minus 15 volts. This amplifier is designed to operate with a limited input voltage range of minus 1.5 volts to plus 1.5 volts. Only within this range of input voltage, the amplifier will provide a gain of 10. Any voltage beyond this range, the output of the operational amplifier will be saturated either on the positive side or on the negative side. You might have a question: is it okay to operate this amplifier beyond plus 1.5 volts and minus 1.5 volts? The operational amplifier would have a maximum limit of voltage that the input pins can handle. If the input voltage keep on increasing beyond this limit, the operational amplifier tend to fail. Let us consider an amplifier with a single power supply circuit, which means the positive power supply is connected to plus 15 volts, whereas the negative power supply is not connected to minus 15 volts. Instead, it is connected to ground or 0 volts. So let us plot the input-output characteristics of the circuit. For the positive range of the input signal, the operation of the amplifier remains similar to the previous example. Beyond plus 1.5 volts, the output voltage will start to saturate. But for any negative input signal, the operator will start to saturate at 0 volt. It do not amplify any signals on the negative side because the negative power supply is connected to 0 volts and the output will saturate to 0 volt. Back to the question. So if I want a 1000 volt power supply, can I use an amplifier of gain 1000 and feed in 1 volt to get 1000 volt output? In order for an amplifier to generate an expected output voltage, say 1000 volt, the amplifier must be connected to a power supply which is higher than 1000 volts. The process of amplification is suitable only for a signal, not a power supply. If we have to generate an higher voltage power supply from a lower voltage power supply, there are few topologies of power converters that would be capable of doing this operation. A good example will be a boost converter. The idea of using an amplifier circuit in order to generate a higher output voltage is not a very advisable one. When I was explaining the operation of an amplifier with plus 15 and minus 15 voltage as power supply, I had mentioned that the output would saturate at plus 15 or minus 15 volts. The general purpose amplifiers with the power supply connected to plus 15 and minus 15 volts will tend to saturate approximately somewhere near plus 13 volt on the positive side and minus 13 volt on the negative side. This limit actually varies from op-amp to op-amp, and you can find this data on the op-amp datasheet mentioned as output voltage swing or output voltage range. There are some special type of operational amplifier called rail-to-rail operational amplifiers. This type of op-amp is specially designed so that the output swing of this device can go very close to the power supply lines. I hope this video has been useful to you. Let me know in the comment section and hit like button if you like the video. Share it with your friends and other engineering colleagues. See you on another video. Bye bye from Surya.